Hello everybody, and welcome back to my FNA game engine video series. Today we're going to take the empty FNA project that we set up in the last video, and we're going to load an image and draw it to the game window. Also, I'll show you some other key functionality in FNA, such as changing the resolution of your game window and detecting user input. All of these things are core things that you'll most likely do in your own game at the end of this series. So let's dive right in here. I already have the project opened up, and the first thing I'd like to show you is how to change the resolution of the game window. So if you've ever played a computer game before, whenever you go into the options menu, you'll usually find the ability to change the game window from being full screen to windowed, and you can also change the dimensions, how wide and how tall the game window actually is. And we have the ability to set those things from FNA with some handy dandy functions. Over here in the Game 1 constructor, I'm going to start some new lines below here. And remember the graphics device manager I talked about briefly in the last video. I said that holds information like what resolutions our graphics card can actually draw at. Because remember, some computers might be able to draw at 1920 by 1080. But if you have an older computer, maybe that resolution isn't supported. So all the information is in our graphics device manager. I want to set our game window to be 1280 by 720. That's usually a good resolution that most computers support. So let's type graphics dot preferred back buffer width. And we'd like the width to be 1280, like I said. Next, we can set the preferred back buffer height by saying graphics.preferred back buffer height. And we'll set that to be 720 pixels tall. There's also a bool inside the graphics device manager called isFullScreen. And for now, we'll set that to false. And finally, to apply all of these settings, we would say graphics.apply changes, and this will send the information we just set back to the graphics card and make all of this actually happen. So now when we press F5, we should see a bigger game window than we did before. It should be 1280 by 720. If your graphics device does not support 1280 by 720, I believe FNA will try and find the nearest resolution that's supported. Alright, and there it is. So notice the window is a bit bigger than what it was in the last video. We could also exit out here, and I'm going to change isFullScreen to be true. Now, warning, if you don't have the ability to exit your game, you can sometimes get locked into or stuck in full screen mode when you're debugging your code or if your game crashes. So I usually recommend developing in window mode, but just for sake of example here, I'm going to press F5 and show you. Yep, see here, now the entire screen is filled with the cornflower blue game screen. I'm going to press Alt and F4 at the same time to close out, and I'm going to set this back to false. So now I'd like to go to the Michael Hicks toolbox that you downloaded from the video description, and inside the code folder, there's another folder called Utilities. And inside this Utilities folder, there are 6 C# classes that I have provided for us. Some of these classes I wrote myself, and some of them I took from resources online. Some people wrote the code and were nice enough to give it away for other people to have. And we will use these classes throughout the video series to help us do various things. So here, there's a camera class that we will eventually use to have a camera in our game that can go left, right, up, down, all around our game world. We're going to not use all of these today, but I want to go ahead and put them in our game engine. So let's go back to our project in Visual Studio, and let's right-click Game Engine, and let's say Add New Folder. And I'm going to call this folder Utilities. I like to have folders in my solution in Visual Studio for code that I might not want to see a whole lot. Most of these utility classes we're just going to add to our project and never look at again. So it's nice to kind of tuck them away in this folder here. I'm going to highlight all these classes and then drag them into the utilities folder in Visual Studio. Okay? And now we have all these utilities classes inside the utilities folder. But if we try to build our game, we would run into some errors. And that's because the namespaces in our classes are different from the namespace that we're using in game1.cs and program.cs. Notice our namespace in game1 and program is game engine, or whatever you named your project. And in my utilities classes, the namespace is FNA class code. That's because I was using these classes in a different named project, but this is easy to fix, okay? We'll just copy the namespace from game1.cs, so for me it's game engine. I'll hit Control-C, and then paste it here, and do this for all of the classes. So, game engine. Here's the resolution class. Change that namespace. Texture loader namespace. And then finally, the XML loader namespace has been changed as well. So you'll notice that after changing the namespaces for all 6 classes, XML helper still throws some errors, and that's because it's trying to use code that we haven't written yet. But don't worry, we'll come back to this later. For now, let's just comment out all of this code so Visual Studio doesn't complain. You can comment out multiple lines of code at the same time by highlighting everything. And then up here to the right of the Start button, there's a button that says comment out the selected lines. I'll press that. And if you ever want to uncomment out a bunch of lines, the button to the right here will uncomment things out. So that's actually a good thing to know. It's very useful to do that. Alright, so now all the errors should be gone. I'm going to press F5 and make sure the game still runs. And it does. I'll exit back out. And now I'd like to go back to the Michael Hicks toolbox, and inside of the art folder, there's a bunch of art that we'll be using throughout this series. There's a file here called Sprite, and this is actually some art from my game Pillar. This is the Shy Boy character that you play as during the Distant personality, if anyone's played Pillar. And we'll be using that today. We'll load in this sprite and draw him to the screen. So, let's go back here to our game engine. And we're going to right-click Game Engine and go to Add, Folder, and we're going to call this folder Content. Now, it's important that you spell this folder correctly. Make sure it's capital C, Content, because over here in our code, we're saying that the root directory of the Content Manager is Content. So we want to make sure those two names are synced up. And now we can right-click the Content folder and go to Add, Existing Item. Now we can navigate to where you save the Michael Hicks toolbox. So for me, I put it on my desktop right here. Go to the Art folder, and then down here above the Add and Cancel button, make sure you have all files as the selected filter. That way we can see the art. And from here you can double-click Sprite, and it will be added to the Content folder. Now, we need to change some properties of this art asset. Let's click Sprite, and then down here in the Properties window, we have some different things we can change. But the thing we're concerned with is the Copy to Output Directory option here. We want to change this to be Copy if newer. And whenever we're building our game and we make that final executable file that runs, we want to be sure that while we build the content, we want to move the sprite.png file to that output directory next to the exe. That's important because this will be a required file that the game needs to run. You can't run a game and draw assets when you don't have the assets to draw, right? So we want to make sure the sprite.png file gets moved over to our output directory next to the executable file. Now that we have the sprite in our project, we need to create a variable to load the texture into. And luckily for us, there's a perfect variable in FNA called texture 2D. And like it says, this is to store a 2D texture, and 2D textures can be JPEGs, PNGs, any type of normal graphical 2D asset, right? Let's call this variable image. And then there's a perfect place in our Game1 class to load in graphics. Do you know what that function might be? I hope so. We talked about it briefly in the last video. Load content is the place you want to load in textures and other game assets. So let's say image equals texture loader dot load, and then once you put the open parentheses sign, you'll notice we have two things we need to pass in to this function. We need to pass in the file path, which for us would just be Sprite, because that's the name of the file. And then the second thing it's asking for is a content manager. A content manager is what's used to load in all of our game assets. We already have one defined for us, and it's called content with a capital C, so we can just pass that in, and then semicolon at the end. So now that we've actually loaded in the image we want to draw, we need to actually use this variable and draw it to the screen. So down here in our draw function, surprise, surprise, this is the perfect place to draw a sprite. And we'll be using the Sprite Batch variable that we talked about in the last video to draw all of our sprites in one big batch. So to start a Sprite Batch, we'll say Sprite Batch.begin. And I'm going to put a couple lines here, and Sprite Batch.end always needs to be called when we're done drawing our sprites. So in between here, in between the begin and end, this is where we could draw everything in our game. So we would draw all of the backgrounds, all of the buildings, all of our people, all of the power-ups. Everything could be drawn right here in one Sprite Batch. For now, we just want to draw that one image we loaded in. So let's say Sprite Batch.draw. It's asking for a texture 2D, and we just loaded a texture 2D called image. Next, it's asking for a rectangle, but as you can see, when you press down and up, you get different types of things you can pass into Sprite Batch.draw. I'd like to use the second parameter list where it's asking for a vector 2. I think that's a little easier to work with. And let's say new vector 2. 0, 0. Oops, no comma there. And then comma outside of the parentheses, and here we'll say color.white. Semicolon at the end. Now, a vector 2 is what we'll use to store the coordinates we want our image to draw at. So because this is a 2D game, we have the x coordinate and the y coordinate. The x goes from left to right, so let's say 0 is usually the very left side of a window. If we wanted to move the character to the right, we would maybe move him 5 pixels to the right every frame until he's at 1280, because 1280 is how big our game window is. And then if you wanted to move to the left, you would subtract from the x-axis. For the y-axis, the way it's oriented is if you want to move down, you would add to the y-axis and subtract to the y-axis if you want to move up. So for now, when we say new vector 2, 0, 0, this should be the top left part of our game window. The last thing we passed in here is a color, and if you would want to change the color of the image, you could do it here. So sometimes in games when your player gets hurt or an enemy gets hurt, you might see the sprite flash red really fast. You could do that here by passing in color.red for maybe 60 or 80 frames, something like that, and then moving it back to color.white when you want him to draw normally. So let's go ahead and press F5 and see if our guy draws. Ah, yeah, check that out. So there's little shy boy there in the top left corner. Everything's going as planned. I'm going to exit out really fast, and let's make this color.red, just to show you how that works. And notice the sprite is now drawing red. So that's pretty cool that we can draw a sprite to the screen, but usually in games you don't just draw static people to the screen, you also move around a little bit. I said earlier that this second parameter here, the vector2, is the position we want to draw the image at. So we can define another variable called position that is a vector2, and we can update that variable to move the character around the screen. So let's go ahead and do that. Let's go back up to the top of our game1 class, and right underneath the texture2 image, I'm going to make a vector2 called position. Down here in the initialize function, I'm going to initialize position to be a new vector2 at 640 by 360. And I'm picking those numbers because that is 1280 divided by 2 and 720 divided by 2, so that should start our sprite in the very middle of the screen. Last but not least, we need to pass in the position variable into the sprite batch.draw. So let's replace our new vector2 0 0 with the variable position. I'm going to press F5 and we should see the sprite in the middle of the screen. Yes, that's pretty centered. The reason it's not perfectly centered is because if you look at the asset, notice, well, you can't really see it there, but yeah, here you see in Windows Explorer, notice he's in a full box there and he's centered inside of that box. So there's a little bit of this extra space over here, and so technically the very top left corner of this image is what's being drawn in the center, and that's why when you look at the game he looks just a little offset. So we could fix that, but that's good enough for me for now. I'm going to exit out, and now I'd like to detect keyboard input so we can actually move our guy around on the screen. And usually in computer games you use WASD or the arrow keys to move your character around. We will use WASD in this example, and depending on what button was pressed, we'll update our position variable to either move the sprite to the right, to the left, or above or below. So here in the update function, I'm going to start at the top of it, and I'm going to say if input dot is keyed down, parentheses, keys dot, and then here we have all of the keys that we can check. I'm going to say keys dot, let's start with the x-axis. I'll say keys dot D. If the D key is being held down, we will say position dot x plus equals 5. So if we hold down the D key, each frame we will move 5 pixels to the right. Else if input dot is key down, keys dot A, we will move position dot x left. So D will move us to the right, A will move us to the left. And then below here, I'm going to, actually let's copy and paste this. And here I'll say if keys dot S is being held down, position dot Y will be moved 5 down. Otherwise, if keys dot W is being pressed down, we will subtract 5 from the Y position, and that will move us up. So there's one last thing we need to do for this to work, and that is we need to call update on my input class. That way the input class has the most up-to-date state of the keyboard. So we'll say input.update, semicolon, and my class will take care of everything else. It'll make sure all the variables are up to date, and then when we're checking is key down below here, all of that should be up to date. So let's press F5 now and see what happens. I'm going to press, yeah, there we go. I'm pressing WASD, and now we can move the sprite around the screen. That's pretty cool, huh? I like that. Let's go ahead and take a quick look inside my input class just to give you an idea of how things work. And under utilities, we can go to input.cs, And here I'm storing some variables for checking the keyboard state. A keyboard state basically holds the information for every single key on the keyboard and tells you which keys are being held down or not being held down. And here I have some variables for the mouse state, which tells us if a mouse button has been clicked and where our current position is of the mouse, things like that. We have the key down function here that we were using earlier. Here we have is key up, which tells us if a button is not being pressed. And then here we have a key pressed function. And notice that I'm storing two different keyboard states, one for the current state right now in this frame, and then I'm also storing a keyboard state for the last frame. So in our code, we are only detecting if a key was being held down. But sometimes you want to detect if a key has been pressed. And what I mean by a key press is that sometimes you don't always want to be doing something every frame that a key is being held down. Sometimes you just want to do one thing on the initial frame that the key was being pressed. So say you're in the main menu of a game and you're wanting to go down one option at a time. To do that, you would want to see when the key was initially pressed and then let up again. And then the next time you press it down, you would go down another option in the menu. And to successfully detect these types of things, you would need to store the keyboard state for the current frame you're in, and then the last keyboard state for the previous frame we were in. So here I'm saying if the key we're checking for, say it's the down button, if the down button is currently pressed down and it was not being pressed down in the last frame, this is the initial frame that we've pressed the key down. And this will never be true again until we let up off of the key and then press it down again. Okay? So you'll most likely want to use this function when you're doing main menu input or other scenarios where you're not wanting to do something every single frame that a button is being pressed down. There's some other functions here for detecting if the mouse is being clicked on the left side or the right side. Here it tells you the position of the mouse. Basically, you don't need to worry about what's being done in here. I just wanted to explain the key pressed function because I feel like that's important. But from here on out, we can just use these functions and not really enter this class again. You can exit out and never look at it ever again. And that does it for this video, everybody. I hope you enjoyed loading in an image and moving it around the screen, detecting some player input. In the next video, we'll continue expanding our engine, and I hope to see you there.